Have you ever just stopped and wondered how the apps on your phone or the websites you use every day actually work? I mean, it can seriously seem like magic, right? But here's the thing. It all starts with just a few simple, really powerful ideas. So today, we're going to pull back that curtain and take a look at the fundamental building blocks of all code.
So, how in the world does one simple instruction, just a single line of text, somehow transform into something as complex and powerful as a social media app or a massive video game? Well, the answer is that every single program out there, no matter how huge, is really just a collection of small logical building blocks, stacked one right on top of the other. And today, we're going to see exactly what those blocks are. You know, before anyone writes a single line of code, every great program starts as something much, much simpler, an idea. And that idea, it needs a plan. This is, hands down, the most crucial first step, and it has absolutely nothing to do with a computer. It's all about clear thinking. Now, in the programming world, we have a fancy word for that plan, an algorithm. I know, it sounds super technical, but it's really not. Just think of it as a precise step-by-step recipe for getting something done. It is the blueprint we create before we even think about picking up our tools. And believe it or not, you use algorithms every single day. Just take your morning routine, which we've laid out here like a little flow chart. Waking up, that's your first step. Then, boom, you hit a decision point, a question. Is it sunny? And depending on the answer, your algorithm branches. If the answer is no, you follow that path to do something specific, bring an umbrella. And see how both paths eventually lead to the final step? Leave. That is a perfect, simple algorithm. Just a series of steps and decisions to solve a problem. Okay, so we have our blueprint, we have our algorithm, but how do we communicate this plan to a machine that really only understands ones and zeros? Well, we need a translator. We need a programming language. And there are a ton of languages out there, each with its own strengths. You've got JavaScript, which is basically the powerhouse of the entire web. There's Scratch, which is amazing for learning visually. But for this explainer, we're going to focus on Python. It's famous for being super readable, really powerful, and it's a top choice in huge fields like AI and data science. So yeah, it's pretty much the perfect language for showing off these core ideas. All right, let's get into it. It's time to build our foundation with the two most fundamental blocks in all of programming: the ability to store information and the tools to actually do stuff with it. First up is the variable. Honestly, the absolute simplest way to think about a variable is to just picture a box. That's it, a box that you can slap a label on and then put a piece of information inside to use later. It's just a named container for data. And this is exactly what it looks like in actual Python code. When we write city equals Tokyo, we're doing precisely what I just described. We're telling the computer, hey, create a box, a variable, and label it city. Then, and this is super important, that single equal sign isn't asking a question. It's what's called an assignment operator. It means put the thing on the right, the word Tokyo, into the box on the left. So we've got our data stored away in these variable boxes. But what can we actually do with it? That's where operators come in. They are our toolkit for performing actions. You'll recognize the basics, of course, like addition and subtraction. But programmers also have these other cool tools, like the percent sign to find the remainder of a division, or the double asterisk to calculate exponents. These are the basic verbs of our language. Okay, so we can store data and we can do some basic math. But let's be honest, right now our program is basically just a glorified calculator. The real magic, the fun stuff, happens when code gets smart, when it can repeat actions all by itself and make its own decisions. So let's look at the building blocks that make all of that possible. First up is the loop. Just imagine you needed to print a message 100 times. I mean, you could write the same line of code 100 times, or you could use a loop. A loop is just a block that tells the computer, hey, repeat these instructions over and over again, which saves us an incredible amount of work. So let's break down a for loop in Python. That first line sets it all up. For a temporary variable that we're just calling I, go through the numbers in the range starting from 0 up to but not including 4. You see that colon at the end? That signals that a block of code is about to start. And the print I line is indented. That's how Python knows that it's the code inside the loop. So the computer sets I to 0 and prints it, then sets I to 1 and prints that, all the way up to 3. All right, next up, how does code make decisions? Well, it starts by asking a question, and it uses these tools to do it. Comparison operators. And look closely. Notice the double equal sign. That's how we ask, is this value actually equal to that value? We can also ask if something is not equal, or greater than, or less than. And the key thing here is that these operators always give us a simple answer, true or false. And this is how we use that true or false answer. It's called an if-else statement, and it works exactly like that decision diamond in our morning routine flowchart. The program asks a question using our condition. If the answer is true, it goes down path A and runs that code. But if the answer is false, it takes a different turn and follows path B. This is the fundamental way a program makes a choice. It's a fork in the road. So, as our programs start to get bigger and bigger, just having single variables and simple instructions isn't gonna cut it. We need some building blocks that help us manage all that complexity. So let's look at two of the most important organizational tools we have: lists and functions. Okay, so if a variable is like a single box, then you can think of a list, which is what Python calls its version of an array, as one of those trays with multiple ordered compartments. It lets us store a whole sequence of related items all together under just one name. For example, we could create a list called week. But now, listen up, because here is the most important rule about lists, and it's something that trips up pretty much every new programmer. Computers start counting from 0. So the first item in the list isn't at position 1, it's at position 0. So to get that first item, mon, we use the list's name followed by a 0 in square brackets, just like this, week 0. And finally, we have my personal favorite, functions. A function is like creating your very own custom Lego brick. It's a block of code that does one specific job, and you give it a name. Then, anytime you need to do that job, you just call the function by its name instead of writing out all the code again and again. It is the ultimate tool for staying organized. Let's see one in action. First, we have to define the function. We use the little def keyword, we give our function a name, in this case area, and then we tell it what information it needs inside the parentheses. This one needs a base and a height. The indented code is the function's job, to calculate the area. The return keyword tells the function what value to send back once it's done. Now, after we've defined it, we can call it by its name, giving it actual numbers, like area 10.5. The function runs its code, returns the value 25, and our program prints it. We can now reuse this area block anywhere we want, anytime we want.
So we've looked at a whole lot of individual pieces, haven't we? Let's take a quick step back and see how all of these different blocks fit together to build, well, pretty much anything. This is it. This is your complete toolkit. Every single app, every website, every piece of software you have ever used is built from these 6 fundamental concepts. You store data in variables and lists, you mess with it using operators, you control the flow of your program with loops and conditionals, and you keep it all neat and tidy with functions. That, right there, is the blueprint for everything. You know, from these few simple building blocks, entire digital worlds are created. The only real limit is your logic and your imagination. So the question isn't just, what are these blocks? The real question is, now that you know what they are, what incredible things can you imagine building with them?